Classical versus Bayesian probability. Coming to probability, there are two major approaches. First one is classical approach for probability and the second one is Bayesian approach for probability. Depending on the approach that you choose for solving your problem, the probability that you find for one particular happening would differ. So it would differ if you choose a classical approach and you choose a Bayesian approach. Now, which approach do you want to choose for one particular situation? That depends on the situation and what sort of a final result do you want. So we'll go through both these approaches and what changes it makes when you choose a classical approach and when you choose a Bayesian approach, right? First, let us see classical approach. What it does is it finds probabilities in terms of frequencies of random repeatable events. That is in terms of classical approach. That is, initially when we started learning probability, when we wanted to find the probability of some event, let's say A, how did you find it? Let's say your problem is to find a fruit from a bag. Let's say this is your bag. Inside this bag, there are a lot of fruits. Let's say many apples, many bananas, a lot of pineapples, oranges, grapes. Let's say a lot of fruits are there. The experiment is this: you would randomly pick one fruit, you will observe which fruit that is, and then you will keep this fruit back in the bag. This is the experiment. Then you want to find, let's say, what is the probability of picking an apple. This is what you want to find. In classical approach, how will you find it? This is what we learned in the very beginning of our probability lectures. If you want to find the probability of finding an apple, first thing you do, you repeat this experiment a lot of times. Let's say you repeated it 100 times. When you repeated it 100 times, let's say 12 times when you picked a fruit, apple came out. From this bag, apple came out, which means your probability of picking an apple is 12 divided by 100. That is the number of times you picked an apple out of the total number of trials that you did. This is the probability of apple. This is how you find it in classical approach. So here you go purely based on your observations, and this is a very objective method. That is exactly based on what you had seen, you are deciding what is the probability of picking an apple or whatever event. And coming to Bayesian view, what do? You have a quantification of uncertainty, and moreover, the difference comes that is introduced is about a prior. You initially will have a prior probability. Here, in terms of classical, you didn't make any assumptions about whatever is happening in this bag. You actually did the experiment and then you found out this is the probability of apple. Instead, if you are using a Bayesian approach, first you will have a prior. That is, before you start this experiment, you will say, I am fixing some prior probabilities. That is probability of picking an apple. Let's say I am picking it as 20 by 100. This is my prior probability. Then based on whatever I see or whatever data I have, I'll modify my prior probability in order to find posterior. This is what I do in Bayesian approach. So how do you find the posterior from the prior? This is the whole idea of Bayesian. So the difference is basically that in Bayesian you are having an initial guess, an initial estimate called prior, and then based on the data that you have, you will modify this prior to get posterior, and this posterior is your probability. Let us understand this from a different angle. Let us say you did this experiment of picking apple, same experiment. Let us say instead of 100, let's say you did only 10 times. 10 times this time. What happened? All the 10 times, coincidentally, let's say all the 10 times apple came out. There is apple, banana, pineapple, everything other. But when you did this experiment 10 times, all 10 times you got apple. Now, what will the classical approach say? According to the classical approach, probability of apple is 10 by 10. That is 1. Because according to the observations that you had seen, all the 10 times you got apple only. Which means, according to the classical approach, all your future pickings, let's say after this you made one picking, next picking, next picking, next picking, all these times, your classical probability predictor will always predict apple. But is it true? No, it is not true, because there are a lot of fruits inside the bag. Anything can come out. But because your experiment, 10 experiments, every time apple came out, your classical predictor would say that the probability of apple is 1. all the future predictions will be Apple. But but what if you used Bayesian? What if you used Bayesian model? In case of Bayesian model, what happens is this time you have a prior. That is, you are saying you have some prior probabilities. You will fix, let's say, probability of apple is 20%, 20 by 100. This is your prior. And probability of, let's say, banana is also 20 by 100. Similarly, for all fruits, you will initially have a prior probability. Now, based on your observation, you will modify your prior, but even if your observation, your data says that it is always apple that is picked, still because of your prior, you won't have go for the extreme bias where you say probability of picking apple is 1. Instead, there will be higher probability for apple because your posterior is dependent on prior as well as your data. How do you find the posterior? That is using Bayes theorem. We had seen it in the previous lectures. I'll explain it once more. That is, let us say you are doing, let's say, some curve fitting. Okay, you want to find W. W is the coefficient. You remember curve fitting, right? You wanted to find Y in terms of W and X. That is W0 plus W1X plus W2X square plus, like this you wanted to find W. So in the machine learning problem, in order to find the curve fitting, you are given X, you want to find Y as the final answer using this. So your machine learning problem is to find the optimal values of W, W0, W1, W2 and all. This is your problem. You want to find W. So in Bayesian approach, how do you find this probability of W given the data? Let's say you are given some data D. So probability of W given data. This is your posterior. How do you find this posterior? You will have a likelihood, that is probability of data given W into probability of W divided by probability of data. So here, this probability of W, this is your prior. This is your prior. This prior, you are fixing this before you start the experiment. So based on your knowledge, you are fixing this prior before you started the experiment. Then based on the data that you had seen, you will modify this prior and reach P of W given D. That is probability of W given the data. Before the data itself, you had this prior. Given the data, you find P of W given D from this Bayes theorem. Here, this P of D given W, this is the likelihood as we discussed. And then from this, when you find P of W given D, you get a probability distribution. So what is the importance of having a probability distribution than a point estimate? That is, in classical, you get a point estimate, that you get one exact value of W. Instead, in Bayesian, you get a probability distribution. That is, this is a posterior distribution. The importance of distribution is this. See, let us say you are trying to make some decision. Let's say you want to make investment. There are two different businesses, business A and business B. You want to decide whether you want to put your money into business A or you want to put your money into business B. Let's say total money that you have is some 100. Okay. This 100, I'm not defining units. You can consider whatever. It can be 100 crores, whatever. So you want to decide where to put this money into. You see the probability of success of each business. Let us say you used classical model. When you use classical model, let's say you got the answer that A is having the higher probability and you have to invest in A. But this time you just have the probability of A. You don't know about the uncertainty. That is, when you found the probability, there may be some uncertainty in the value that you found, which you don't know. In classical, you just have the final answer and no idea about uncertainty because you have a point estimate. Let's say classical model gave you that A is better. You invested everything in A. But later, you got to know that this estimation actually was not a very certain estimation. There was very high degree of uncertainty because of which A and B were equally probable. So in that case, what would you ideally do? You would distribute this money, let's say 50 here and 50 here, or maybe 60 here and 40 here, whatever it be. So for this idea, you need to know the uncertainty. What Bayesian approach would give, it will give you a probability distribution. It will give you a distribution like this. So from that, based on the distribution, you will know how certain or uncertain is the estimate that you are finding. So you will be having an idea that, okay, my probability estimator says that I should consider A better, but there is a high degree of uncertainty in this decision. So ideally I should put a bit into B and also into A. This is what Bayesian adds. So let us go back to finding W in curve fitting. Finding W. Consider classical approach. What happens in classical approach? What did we say? This normally we use least square regression or something like that. And when we are using this in classical approach, it typically does not explicitly model uncertainty in the coefficient W. Instead, it gives a point estimate for W. So what is a point estimate? Let's say you will use maximum likelihood estimator, MLE, or something in order to find whatever according to you is the best value for W for this particular problem. So you just have that best fitting parameter for this particular chosen model for the observed data. So there is no measure of uncertainty or anything. And what happens in case of Bayesian approach? In Bayesian approach, first you have some prior beliefs, right? Some prior beliefs about W. Then based on the data that you have, what you will do, you will find a posterior distribution. You will find the posterior distribution of the coefficient W. What happens now? This reflects both the prior belief as well as the information confirmed in the or contained in the observed data. So in Bayesian, you are considering your prior belief and your data and you finding the posterior. And instead of the point estimate, this time you have curve fitting provides a full posterior distribution for the coefficients. So this will give you a better interpretation. That is the whole thing. So and what impact would this have? That is classical approach. It is suitable in those situations where point estimates are sufficient. That is one particular value of W that is sufficient. There is no need for explicit uncertainty analysis. Bayesian approach, it is beneficial. Bayesian approach, it is beneficial when uncertainty quantification is critical. That is, you want to know how much is the risk in this particular decision. So in case of decision making problems, risk assessment, you need Bayesian approach. So going forward in machine learning, we'll see Bayesian approach being used. Okay.